Okay, let's try some problems from chapter 12. Alright, we have an electron has that charge. How many electrons would be needed to produce a net charge of 4.8 times 10 to the negative 6 coulombs? Okay, this is a conversion factor problem. We're wanting to convert coulombs to electrons. And it says negative 1.6 times 10 to the negative 19th coulombs is how much charge one electron has. Okay, here I can write out electron for you. There we go. Okay, so we have our conversion factor. We have our ratio. We can write that as negative 1.6 times 10 to the negative 19th coulombs over 1 electron. Or we can write it as 1 electron over a negative 1.6 times 10 to the negative 19th coulombs. Okay, so that's our conversion factor. We don't start with that. We start with the thing we're given. We have this many coulombs. We want to convert that to electrons. Okay, so let's start that in our railroad track. That's the way I like to do it. Okay, now I can use whichever fraction is going to make my units disappear. I want electron to stay, and I want coulomb to disappear. Well, coulomb's on top here, so I'm going to use this guy because it has coulomb on bottom. Has electron on top. Okay, coulomb's going to cancel out with coulomb, and hey, I got electron left. So in your calculator, put you can negative divide by negatives positive, so you don't have to deal with negatives if you don't want to. But put 4.8 times 10 to the negative 6 in parentheses. Hopefully you have a scientific calculator. Put that in parentheses. Then divide by, in parentheses, 1.6 times 10 to the negative 19th in parentheses. You've got to use parentheses sometimes on your calculators. And if you don't know how to use your calculator in with scientific notation, contact me. I'll show you. You can FaceTime, and I can take care of it for you. I can usually figure it out if I can see it. So just put that in your calculator. The unit is electron. That's what you got left. Let's try to do another one from chapter 12. Two identical brass balls mounted on wooden posts initially have different amounts of charge. One plus 12 microcoulombs, and the other a negative 4 microcoulombs. The balls are allowed to touch and then are separated again. It's annoying me. Okay, what is the final charge on each ball? So here's one ball. Here's another ball. And here's their charges. Okay, this guy has a negative 4 microcoulombs. This guy has a positive 12. Okay, whenever they touch, they're going to allow the charges, electrons really, to flow between these two balls. Okay, so here's how I like to look at it, kind of. We have, let's not call it electrons, let's just call it a charge. This guy has 12 positive things, okay? This guy has a deficit. He has negative 4. Okay, this guy has 12 positives. This guy has 4 negatives. Alright, so we're going to take, whenever they come together, this guy says, okay, well, I'll help you get rid of that negative. So we're going to go 12 minus 4, because this guy's going to give this guy 4 positive things, so then he's going to go neutral. So this guy has 8 positive things left over, and this guy's just neutral then. Okay, and then this is all happening in one thing. I'm just breaking it down. Then this guy says, well, I'll share with you because my charge wants to spread out. These charges they don't want to be together. They want to spread out as much as possible. So they're going to keep jumping over here. But they're going to distribute between the two balls evenly. So we take this 8, divide by 2, so 4 of them are going to stay. and then 4 more are going to go to the right. Okay, 8 divided by 2, getting us the positive 4. So now the balls have a 4 plus charge and a 4 plus charge. Okay, so 4 went over to make this guy neutral. This guy was left with 8, and then 4 more decided to go over because they want to spread out as evenly as possible. So that's your answer right there.